this is kind of an interesting thing because it was a little bit outside of the scope. I wanted to focus in on particularly like how you deploy serverless functions, right, in a declarative way. But one of the things I was thinking of including was using Fission on top of Istio in a Kubernetes cluster, which kind of is built on Envoy, which gives you that automated like open tracing implementation, right? So there's a cool kind of thing there. Yeah, so you did a pretty good job of covering what are the whys of serverless. Thank you. Made my job way easy. Yeah, so let's, I guess, just kind of get into it. The main part of my presentation really is just going to be focusing on like hands-on, practical, from a developer standpoint, how you develop, serverless functions, how you deploy them into, like in my case, a cluster. How do you make changes to it so that you can actually see those changes, right, and so on and so forth. So yeah, all of this is going to be done using Fission. I'm really disappointed that Fission wasn't in one of the we didn't have the icon there, so OpenFOSS and Knative, which are both, I really support those. They also run natively in Kubernetes. I just so happen to be doing Fission because Platform 9 made Fission, trying to focus on that enterprise readiness. But yeah, so one of the cool things about being able to use serverless that runs in Kubernetes, this is mostly a sell for Kubernetes itself, is the fact that you can deploy Kubernetes pretty much on any of the major popular cloud providers, as well as on-prem, right? And that's like the big thing for a lot of people, especially if, for security reasons and whatnot, right? Also, just small plug, Platform 9 is a sort of an open source cloud company. We released tooling called ClusterKit, which allows you to create a Kubernetes cluster in an air-gapped environment, so you can deploy on-prem even without internet connectivity. Hey, so yeah, and that makes playing around with Fission really like easy to do, just on whatever. So the basic premise, I should have built more of a comparison between other serverless like frameworks or functionality, right? Like how you compose them, but I can just explain kind of how Fission lets you compose things. And people say that with serverless, you only focus on the function. You don't have to worry about how it scales or any of that stuff. That's like half true. Like I love serverless, but you still need to worry about how much memory each function has and cold starts. So like, do you keep a warm pool, of containers? And there's a lot of trade-offs there. So basically how Fission works is you have a function which runs in an environment, and you hook that up to a trigger, right? And these can be a bunch of different things. There's even something not pictured here where you can, this is just a single function, like in a hello world type of demo, which raises, show of hands, who has done like a hello world type serverless demo? Just trying it out? Yeah, okay. You're like, wow, this is easy, cool. But like Shannon said, when you have a ton of functions, like how do you start orchestrating, first of all, dependencies between them? Like, do you want them to share any dependencies at all? If some of them are the same language, do you want to kind of only have one package or environment that they all get their dependencies from to worry about? Or if they're like different languages, I mean, what do you do with that? Do you scope them based on like responsibility? There's a lot of things to worry about there. So yeah, this is, why serverless, blah, 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 blah. Makes you able to throw in Go functions anywhere you want, which is super nice if you're trying to get away from Node. Yeah, I really like serverless for the testability of them. It's super nice. Yada, yada, yada. Yeah, so kind of already went that. So serverless, I think, fits in really well with like this DevOps pipeline. Like there's a lot of places in here that are, I mean, they're all events, right? Like deploying to staging and production and all that sort of stuff. You want it to be event driven. You don't want to have a DevOps engineer sit there for many hours watching a deployment and like manually testing a canary deployment and everything like that. And then, okay, upgrade and so on and so forth. So these are just, in general, some of the best practices, in my opinion, going from dev to production with serverless, right? But the things that we're really going to be focusing on in the talk here is this, especially the declarative configuration, because just me personally using, a serverless framework, once you start to get enough functions, it becomes a challenge keeping track of everything, right? I'm going to run through a couple more slides, and then I'll just kind of pull up the terminal, pull up VS Code, and we'll show you what we're working with here, right? But if you don't know what declarative configuration is, it's basically like if you've ever used Kubernetes, it's exactly that. You specify some state declaratively, and then there's a controller or something that converges on that state, which is perfect, right? Allows you to do a lot of one-click deploys, a lot of GitOps stuff. It's great for testing your functions iteratively. Fission's built using CRDs, which is great, and you never want to write YAML by hand, and that goes for everything involving YAML. Never write YAML by hand, please. It's so error-prone. And packaging is kind of what I was talking about earlier in regards to dependencies, but at least the way that we kind of made Fission, we give you a lot of control over how your functions are packaged, right? I think with AWS, you just sort of upload this zip, which contains everything. This is essentially the same thing. We give you these builders out of box, but there's a lot of control over what you put in that zip and how you zip it and what you copy over and whatnot, right? So the Fission spec function is the thing that we're going to be using a lot of. I wouldn't recommend even, unless you're toying around with Fission, I think this is the best way to get started with it and even use it. Yeah, so, well, this is just kind of a mention of live reload, right? You keep watching your files. Yeah, you have this spec watch, which just uploads the changes when you make a change to the function. And there's the cold start problem that Shannon mentioned. You're always going to be making this trade-off. So I can explain how we solve that, really mostly in the demo, but here, I think in this next slide. Here, sorry.
If you're running in your own cluster, can't you manage the cold start yourself?
Yes. Exactly. And so this is what this is. So there's a couple different mechanisms, right? And this is on here because I actually consider this part of like serverless composition, right? You do have to worry about this. You could just run, when you run your serverless functions, you know how important that function is. You know if it needs to have very low latency, or if it can have a long cold start, or whether or not you want it to be horizontally scaled across your cluster, right? So you can configure all of this in a declarative way. So there are two of the main ways that you can do this, at least with Fission, which takes a lot advantage of a lot of Kubernetes primitives. There's this pool manager, which basically has a bunch of pods with these environments in them, right? That a function will get kind of loaded into. So it gets loaded into a pod specialized with whatever package or archive, right, you'd configured it to use. And then there's like this grace termination period. So subsequent requests to that function will go to that pod that has that environment already ready to go, right? But then after a certain period of time, if that function's not getting called, then the pool pod kind of gets freed up for other functions to get like thrown in and specialized and used, right? But if you have functions that you really care about and they need to have low latency and you expect them to be like slammed really hard, then you can set this up with a deployment and deployment in Kubernetes, right? You specify how many pods you want for that deployment, and in this case, you're able to create this new deploy while specifying a bunch of min and max, like scaling as far as the number of replicas, so the number of pods you want it to scale up to and down to based on however metrics, right? And it's all declarative, which makes sense. Yeah, so this is kind of what I'm wanting to, I just want to give like an overview of what I'm going to be trying to show y'all. Direct function invocation, that is one method of composing functions, right, together. There's the event-driven style of executing functions, and in this case, I didn't set up like a Kafka or anything like that, or NATS, streaming, because really that's what Fission Workflows does. So Fission Workflows is another project that is built on top of Fission that is basically step functions, right? Just open source step functions. There you go. And then we're going to look at packaging and source code organization in general using these specs. So let's see.
Declarative configuration is for multiple functions.
Yes.
That you're going to orchestrate.
That is correct. So I guess I can go here first, and we can just kind of get a little overview of what we're even looking at, right? So in here, I have this declarative directory, and I have a bunch of directories. The one that we really care about in this case is specs. Specs is when you go to create a Fission function or route or whatever, you can basically specify another flag called --spec, and it'll generate the YAML for you, and then from there you can modify the YAML if you want. So there's a lot of things about like our environment that the functions actually run in that we can tune, right? Including, I just actually added some CPU limits to this environment because I saw some bad things happen in my Kubernetes cluster with a lot of functions. Yeah, just several, like this is the archives that I was talking about. You can specify the directory and then all the things in that directory to be packaged up and included. And in this case, I have the IamCaptainPlanet directory with an IamCaptainPlanet.js file, which it includes its own package.json. So you can have every single function have only the dependencies that it needs, or you can start to share the dependencies between like related functions, right? So this is a case of just specific to this function. And then I have another one, Planeteers, where my entry point to this is actually just sourcing additional functions within this sort of module, I guess, right? And each of these functions is using some utils, some shared utils that I have set up, which, it makes sense. Like if these are related things and they're going to do sort of similar stuff, you might want to share some of that code, so they'll use the same archive. So that means when you make an update to this archive, all your other functions kind of around here will be able to take advantage of them. So yeah, and we can just take a look at like a function spec to see what we're dealing with here.
So Josh, that strategy of common environments is very different from the way you would do something typically with AWS Lambda.
Yeah, correct. Yeah, but you get flexibility in how you want to do it, right?
So a trade-off of this gives you the ability to do it in a more common way, or have each function be a little snowflake that's unique. AWS Lambda sort of forces you down the snowflake path.
Yeah, and I think it's super interesting because serverless is so new that like, what are the best practices for composing, functions together? Like, how do you group them, right? We're still trying to figure that out. Maybe it makes sense to make them all unique and then never like worry about interdependency. It's up to you. I also have this example of, so this is our sort of style of step functions. We have these, this Fission workflow, which the cool thing I like about this is the Fission workflow itself is a function, meaning you could create another Fission workflow which calls out to a function which is a workflow and get this very like nested, composable kind of workflow, right? It's nice, so if you nail down a certain workflow, then you say, okay, for authentication, like here is this declarative way that calls functions, like here's the declarative business logic. And if you want to do authentication, you can kind of use this in another workflow. And there's sort of like, there's built-in concurrency here, like this merge output, which is a built-in function. It just maps, all the output to this. Basically, these three, water, fire, earth, will run and run at the same time. This function waits for them to finish, and then Captain Planet takes that one and runs at the end, right? So you don't really have to worry about the flow there. That's kind of cool.
Is the communication from function to function synchronous, asynchronous? I'm not seeing any.
Yeah, so that's up to you. Basically, think of it as like a DAG. So when you say that this function here requires this, right? What you're saying is I need you to wait until that thing is done before you execute. So it's not explicitly waiting. It's more declaratively saying, hey, I need you to wait for this thing. And if you don't have it wait on anything, it'll just run whenever it can, right? The next time, or it'll just run when it can. So that's actually another thing is how big do you want these like workflows to be such that they're still understandable about what's going on and how concurrent things are. So I have an example here of different ways of invoking other functions, right? So actually in Fission, it uses it is a Kubernetes object. So with Kubernetes, what you're able to do is the entire cluster can only have a single like public-facing entry point, right? All of the functions, like once the request goes into the cluster, you can call other functions without having to leave the cluster, right? I don't know with AWS if it's all within kind of their own VPC or however that's set up, right? Yeah, right. So, yeah, exactly. This is why you have a lot of control over how you want to do this. So, I have this sorting hat set up to where.
In contrast, the thing about AWS right now is A, it's free, and B, it'll be different next week.
For sure.
So a lot of this stuff that's not explicitly specified is a moving target. One of the things I've seen is people are optimizing, the cold start timeouts. Keep changing.
Yeah, and companies are focused on that because AWS isn't giving answers. So.
Yes, which is why it's super awesome to be able to configure your cold starts, right? Like, that's amazing. Open source. So let's see. I don't know if I have stuff running here. Oh, I gotta export this router. Whoops. Okay, I have it actually in here instead. My bad. I was trying to make it easy so I don't have to like flip-flop back and forth. Jeez, what the heck? Hold on. Okay, cool. Can everyone see that? Cool. So,
Live demos.
yep.
Always.
I killed I killed one of my Tmux things on accident, so I absolutely got myself. Dang. Okay, hold on. The heck? Oh, wait, I think because I had done this, I wanted to show an example of how you're actually able to deploy all your functions, right? So if I take a look here and do a Fission function list, I have nothing in here, right? But this is my specs directory, which you can rename whatever. So if I just go ahead and do a Fission spec apply and I wait for it, it will create all my functions and routes and do all the building, packaging, pulling dependencies, right, for everything in the requirements.txt, or it'll compile your Go code and put the binary into an image and whatnot. And yeah, so now if I take a look here, come on, internet. Yeah, so we have all of our functions. How about that? So now, including all of our routes for these, right? And I didn't create too many routes, and which is kind of the point. This is another thing of like function composition is, especially, I guess it's more about with Kubernetes, because with Lambda, there is no kind of concept of a private function, I guess, is there? Yeah, everything is like public, goes over the internet, you hit it, right? But sometimes, yeah, that's private. Yeah. And just to mention, I'm like really a big fan of serverless within Kubernetes. If you can't tell, another really cool thing is if you go to the function spec, you can actually, on a per function level, configure it to use secrets or config maps from within your cluster, which is really neat and useful, right? If you need to load credentials in, you don't have to like figure out this weird way of going over the internet with it. You just put it in your cluster and you don't worry about it. So what I'm wanting to do is, so I have these all configured to use the pool manager, right? So they're gonna have to inject the code into a running pod from that pool and then execute it, right? And so it should be quicker like the second time that I do it, right? So there's an example of kind of the warmed up pod. And so in here, what I'm showing off is this example. Like this is one way of composing functions, right? You could directly call the function from within another function, right? And deal with the maintainability of that as you wish. So here I'm basically just looking at the value of the quality field in that request body, right? And then invoking a different function depending on it. And like, sorry, Hufflepuff. Yeah. So in here, if I did like wisdom or something, or actually wise. So now look, it's taking a bit longer because it had to like load that function into a pod, which is really another interesting thing when it comes to composition, because you get to determine if you through tracing find out that function, that code path is not hit very often, you can tune that function's environment to just be more of a cold start. You don't really care too much about keeping it warm because it's not being hit that much. Right, and then this, of course, requires a lot of like observability and like metrics. All these Fission functions are, it's not about observability, but all these Fission functions are actually hooked up to Prometheus and get everything exported. So that's fun. You can have a Grafana dashboard. We have Fluent Bit that ships all the logs, blah, 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 all the Kubernetes stuff. That's why it running in Kubernetes is kind of cool, because as that ecosystem matures, so too does like the serverless parts that you use it. Yeah, and so I guess I'll give it a little example.
The downside of running Kubernetes on premises is you don't get all of the wonderful stuff that Amazon has to offer, like IAM, and you gotta manage that yourself.
That's super true.
You gotta build up your own infrastructure.
That is super true, yes.
Everything's a trade-off.
It's a trade-off, yeah. My personal favorite way, I don't know if this is biased or not, just side note, because I work at Platform 9, we also do manage OpenStack, and I didn't know what that was when I started, but now I'm kind of a big fan of it because I think the ultimate utilization of your own hardware is putting OpenStack on top of it and then running Kubernetes on top of that such that the nodes are VMs in your OpenStack cloud, and that's just a really nice way to get the most out of your own hardware, in my opinion. So if we do, this is more of kind of a just workflow type thing, but I guess this is still part of function composition, right? If we want to go ahead and add additional things here, I can run this spec watch and it'll watch for changes to my functions and do whatever it needs to do with that. So if I go here to if I wanted to add heart to my I am Captain Planet, right? Or sorry, it'd be my Captain Planet workflow. Then I'd basically just copy this and add heart. And I actually have these functions sleep for anywhere from 0 to 3 seconds to kind of demonstrate that when you put things in a workflow and you set up this requires, right? It just waits for all the ones that it's required to finish before it actually, merges all the output and then feeds it to the next function. And there's a lot of other primitives here, very similar, like I said, pretty much based off of step functions, like if statements and looping and whatnot. But yeah. So if I were to do that, and I want to add heart to it, about yeah, true. Okay, never start YAML by hand. But once it gives you the spec, right? For example, if I wanted to go tune my Python environment, I'm like, oh, okay, cool. Yeah, I can add some stuff to it. For this function, if I wanted to go and add secrets that it wanted to utilize, I think that it'd be fine to edit it here. Just never try and generate that. Come on, do you really want to generate this? Yeah. So basically, this is honestly one aspect of function composition that I don't really like, is this, just right here, having all these directories, and now that your application and all the logic is spread way out, cool, every time you need to go make a change to something, you have to go track down that single file, and maybe that's not, I guess that's more of a best practice in terms of structuring the directories and whatnot, how easy it is to find and make changes. But since I have that watch running, let me actually create. Yeah, I mean, that's true. So here, if I wanted to create this function, I'll do fission function create spec heart. My environment is going to be node. The source in this case is going to be my Planeteers directory, and my entry point is something I'm going to have to add right here, right? So now I have heart that's required. Heart is sourcing my utils. I don't have to change that. It will actually end up using the same archive. So I need to do Planeteers / that. And my entry point is going to be, so basically the source is saying what all dependencies. So in fact, I could call other functions within that same directory if I wanted. It's just like packages in a higher level language, except now, this benefit of, you have this benefit of writing functions in completely different languages, but still being able to invoke like a related, responsible, like a function that has a similar responsibility, but you don't care about what language it was written in. You're not actually calling it at that source code level. It's at the function level, which is kind of weird to think about. But I think it opens up a lot of opportunities, right? So my entry point here is going to be planeteers.heart, right? So let's see what happens with that. So it's reusing that archive, so it doesn't really need to create another one. Cool. If I look here, it did notice a file change. So if I do this fission function list, will we see heart? Wow, we do. How about that? So let's see if we can actually get our workflow, which is now going to have to warm up because like I said, workflow is a function itself. It's currently configured to run in a workflow environment pool manager. So that is still a work in progress. There's no GA release for workflows. There's a lot more work to be done, but I think that as it matures, it may become the basis for perhaps a testing framework, which I'm personally really excited for. Yeah, talk about cold start, right? Dang. Yeah, that might take a sec. And so, yeah, anyways, does anyone have any questions about sort of the flow or organization of these serverless functions to call each other or anything like that? Like, has anyone toyed around with perhaps rewriting a rather small application at either your job or a side project entirely in serverless? Well, yeah, you said 99, 95%? That's incredible. How do y'all keep track of everything? How do you?
We use our own product, and that's why we built it, actually. So
Oh, really?
Yeah, we eat our own dog food.
I mean, that's the best thing you could do, yeah.
I have a question, actually. So what are the best use cases
Damn.
to use Fission or, like serverless on Kubernetes? What do you think are the best use cases for companies as they start their serverless journey instead of managed services?
The best use case? I mean, we have a customer who, I think that for a lot of companies, going entirely serverless is not really the answer. It's more about choosing your battles, right? What makes sense to be serverless? So one of the advantages of using Fission, for example, is if you're already started on your cloud native transformation, your digital transformation journey, and you're interested in kicking the tires on Kubernetes, and you're starting to either deploy monolithic apps in Kubernetes or you're starting to get some microservices deployed in there, it's super easy to be able to just deploy Fission in there and start having your monolithic or microservices either invoke the Fission functions directly or you start using the Fission functions as these kind of helpers, based on like events and whatnot. So I think that it's really good for companies who are not all in, but are all in on Kubernetes. Yeah.
So you mentioned being able to run air gapped.
Mm-hmm.
So something like a intermittently connected edge, or pushing a cluster out to the edge.
That's exactly the use case. Yeah, we had a customer who they wrote their software to run on Kubernetes and they wanted to ship it to the edge, right? It's a networking company. And it needed to be completely air gapped. So sort of like an ISV type
Okay.
thing, right? And so that's what it was built for, and then that's just available now. Cluster kit, look it up. But yeah, that's the use case.
Other questions for Josh?
Yeah.
No? All right, thanks.
Oh, okay.
Thank you.